It feels like every day at the moment that I'm being asked by energy companies, heat pump installation companies, and government organizations why heat pump retrofits are not happening at the rate that they expected. And because I'm getting a bit tired of repeating myself, I'm recording this video to run through a presentation which we did for the Department for Energy Security and Net Zero, or the more commonly known as DESNES. And in this presentation, we outline some of the reasons that we see real customers in homes in the UK who are considering heat pumps go for or not go for heat pumps, and how systems like ThermaSkirt can play into the overall picture of heat pump adoption and help us get towards net zero. So if you aren't already aware what ThermaSkirt is, then this is ThermaSkirt. ThermaSkirt is effectively an alternative to radiators or underfloor heating. It's specifically designed with retrofit in mind, and you can see here a couple of images of it. Essentially, what ThermoSkirt does is it disguises your radiators as a standard skirting board. So it builds the heat emitter within to the fabric of the home, which is very important if you want to maximize space and overall aesthetic. So in terms of the way that it works, you can see there's a bit of a glimpse here, but we will get into it in a minute. But it plumbs onto existing pipework. Obviously, this gets covered over, and you can see from the thermal images that the skirting heats up. And in this case, it's running at 49 degrees C, which is probably the maximum you would ever go on a heat pump. And we designed the systems to much lower flow temperatures than that. So not only is the ThermaSkirt designed to run as a skirting board heating system, but it also can be used as a kitchen plinth. And there's a couple of examples here of the ThermaSkirt being used on kitchen plinths. You can see that we've color matched it here to the plinths. We've color matched it in this example to the plinths as well. So it's an ivory. This one on the left hand side is a green, and the one above, which is in Barrett's house, is just in white. And that's because kitchens, open plan living, dining areas are specifically a very challenging area to install heat emitters, particularly when you're on a heat pump. The other option is bifold doors. So bifold doors are very popular now. Large open expanses of glass, obviously, looks very nice, gives you a great aspect, brings lots of light into the room. But that takes away a wall that a radiator could be installed on. And fundamentally, it means that you have got an area of greater heat loss where you weren't expecting it. So we actually position the ThermoSkirt under the glass. What that does is it generates heat where you need it most. And it also continues the flow of water around the room so that you can basically link up all of your ThermoSkirt systems. So this is proving really popular, particularly on heat pump systems where you need to get the maximum amount of output into that room and you need to offset the heat losses like in glazed areas. So before I get onto the nitty-gritty of the product, I think we probably need to outline the challenges of actually getting heat pumps into the market in the UK. And obviously, the UK is a very conservative market just by its nature. And for that, you need to look at this, which is the technology adoption curve. Now, this adoption curve applies to any industry, whether it's electric cars, whether it was mobile phones, whether it was social media. Every bit of technology goes through this cycle, and it moves from innovators and early adopters over to the pragmatics, the conservatives, and then the laggards, the people who don't want to adopt that technology at all. So, for example, in the case of mobile phones or smartphones, the laggards are people who will still not have a smartphone, whether it's through personal choice or whether they're not interested in the technology, they just don't feel like they need it. They're not going to be moved, and they'll effectively die on that hill. Systems like heat pumps are going to have to go through this very, very difficult curve, and the majority of people are going to be sat around the middle in the pragmatics and the conservative section. Now, one of the things that gets modelled is this, which is called the chasm. And in the chasm, that is the area where sales drop off because you move from innovators and visionaries over to pragmatics. So let's say, for example, 15 years ago, somebody installing a heat pump would have been an innovator, somebody who sees the technology, is willing to give it a go, has the financial capability to introduce it, and they go for it. And then you've got the visionaries, the early adopters, and these are people who still fall within this tech enthusiasts kind of area. They're people who are open to having new ideas, open to trying new ideas, don't need to see that their friends have got one before they do it. And the reason that the chasm exists is because the pragmatics will look at things like the cost, the disruption, the change to their lifestyle, and they'll make a decision based on their own personal circumstances. It won't be a decision made on on a sort of ideology or this thought that maybe there's a nice to have. So pragmatics are obviously very difficult to convert, and you need to show them that there is a physical benefit, an emotional benefit, a lifestyle benefit, or a cost benefit to adopting that technology, and then you'll start to shift them. And I think we're still in the visionary section when it comes to heat pumps, and I think that we may hit the chasm. I think some of the bigger energy companies are currently hitting the chasm, and they aren't converting the number of sales that they want. And the reason that I think that this is the case is because the inquiries for heat pumps are astronomical. The number of people asking for prices is insane. So the interest is there, but the conversions aren't. Yes, there was 25,000 retrofit heat pumps under the bus grant last year. That is obviously great, and it's a big step forward in the right direction. But my concern is that we aren't going to move into the mainstream because there isn't a clear lifestyle benefit to having a heat pump. It's obviously a costly exercise and a very disruptive exercise, and as a result, a lot of those inquiries, whether it's going to Octopus or British Gas or Era or any of the smaller, more independent operations, they're not converting. And that is probably down to this. So in 2023, Energy Systems Catapult published a full report. This is just one slide out of the full report. And in that slide, they talk about the participant journey. So basically, customers onboarding, showing an interest in having a heat pump and then not converting. And this survey was carried out with OVO Energy and a couple of other major players in the market. Now, if you look at the barriers to installation, you'll see here you've got disruption at 68% of participant dropouts, and then practical issues, space, noise, and time, 15%. So effectively, 83% of all heat pump installation dropouts were due to disruption or practical issues. Only 10% technical and 4% economic. I mean, there's a question mark over the economic factors because if you're surveyed and someone says why, you're less likely to say you haven't got the money. However, disruption and practical are not insignificant, and I think that so many engineers overlook this. I think so many heat pump companies overlook this. They just because they're in an echo chamber and they're blinkered and it's heat pump, heat pump, heat pump. They can't understand why somebody possibly might not want one or might not have one, even though they do want one. And a lot of that is down to disruption because in a retrofit, for example, there is a lot of disruption. So if a customer is going to overcome these barriers, there's going to need to be a significant lifestyle improvement for selecting a certain type of technology. So let's look at key benefits. So for example, I've outlined the key benefits of ThermaSkirt, which is what we were doing for DesNes. Fundamentally aesthetics. Everybody or not, believe it or not, cares about what their home looks like, whether it's how tidy it is, whether it's how well decorated it is, or how spacious it is. So aesthetics play a huge role in the customer decision-making process. And aesthetics is something that ThermaSkirt obviously plays into. A lot of people don't want to see big white panel radiators on the wall. Some people may be able to live with them, but there's a huge number of people who don't. Because if those people didn't exist, underfloor heating wouldn't be as big as it is. So clearly there's market demand for better looking or no radiators, i.e. underfloor heating and designer radiators. And in a retrofit example, underfloor heating is very disruptive and designer radiators don't always provide the heat output that's necessary. The other tangible benefit is usable room space. So homes are getting more cramped, furniture is getting bigger, people have more stuff, space is at an absolute premium, an all-time high. And in London, for example, you could be paying anywhere as much as £2,500 a square metre. So for every single radiator that you remove, you're effectively saving £2,000 worth of usable room space. And then you've got efficiency. So obviously, in order for heat pumps to be as viable as possible, you want them to have as low a running cost as possible. And in order to have a lower running cost as possible, ideally, you need the lowest flow temperature possible. Having lower flow temperatures means you need bigger radiators, and the lower the flow temperature, the bigger the radiators. Now, using a product like ThermaSkirt, either on its own or in conjunction with radiators, which I'll come on to, means that you can reduce the flow rate, the flow temperature to as low a flow temperature as possible, obviously increasing the COP of the heat pump and reducing the energy consumption. So how ThermaSkirt actually enables the rollout of air source heat pumps. So reduces major works, which I'll come on to. So reduction in overall retrofit costs just due to disruption. Home improvement. So fundamentally, the resident, the homeowner, has a perceived lifestyle benefit from moving away from radiators. It's not just the heat pump outside, it's also the benefits to the appearance and space inside. And then reduction in complaints. So we have a lot of data from local authorities and social housing providers that we've worked with, which indicate that a heat pump combined with a system like ThermaSkirt or underfloor heating is worth noting. Both of those systems, because they're radiant systems, they're very well distributed heat, they're evenly spread, they're low level. You don't get as much complaints. People think that residents complain about heat pumps, but what they don't complain about the heat pump. What they complain about is their comfort level. A resident will complain about their comfort because they don't really fully grasp whether the heat pump itself is working or not. Unfortunately, it's the heat pump that gets the blame because that's the new bit. When in reality, it's the radiators which are likely to blame. And I'll come on to why that's the case in a minute. And then you've got this disruption issue. So preparing the UK housing stock for heat pumps. Here is some of the considerations that need to be made. Obviously, there's the fabric of the building. How good is the insulation? You need to minimize losses wherever possible. If you've got single glazing and you can have double glazing, then you should be doing that first. That's the easiest way to reduce your energy consumption. You've got hot water storage to consider. Obviously, not something that we do at Discrete Heat, not a challenge that we overcome. But there's systems out there like Mixergy, which means you can have a smaller cylinder, or Sunamp, which means you can store latent energy effectively in a heat battery through a phase change material. The bit that we deal with is radiator sizing. So having to upsize radiators can really put customers off. And if you go into a house to spec up a heat pump and the customer's got designer radiators, trying to explain to them that they're going to have to take those designer radiators out, which they probably spent a lot of money on, and throw them away, is likely going to put them off having the entire heat pump in the first place. And then you've got things like microbore pipework or pipework changes or pipework upgrades, which is a significant source of disruption, which we will address shortly. So radiator sizing, let's take a typical radiator size, a K2 radiator at 40 degrees mean temperature. So let's say your heat pump is 42 flow, 37 return. A 1200 by 600 will give you about 632 watts, which let's say is a typical bedroom. And that is a 1200 by 600 double panel radiator, which is a significant size radiator for a room of that size. Now, the equivalent length of ThermaSkirt would be 14 meters of BM2 or 9 meters of BM3. So that is effectively 2 or 3 walls of skirting to offset that entire radiator size. And the same in the living room, a 2 meter long 600 double. A lot of engineers recommend going over to a triple panel radiator, but if you actually see how far the triple panel radiator sticks out from the wall, for many customers, again, not all, but for many customers, that's a major turn off. Here's an example of a K3. Now, in addition to that, you also have the weight. A lot of these radiators are a 2-man lift, which means it's a 2-man install. You know, they're heavy. You've got to anchor them to the wall. Sometimes you have to put feet on them because they weigh so much. So there's other practical implications of installing something that size. Not only the fact that, in my opinion, it's ugly as sin, but also because of the weight, the size, and the space. It's just ridiculous. We're trying to shoehorn these things into houses that were never made for them in the first place. Now, in terms of the plumbing, obviously people look at ThermaSkirt and think it's totally different to radiators. I'm going to need to completely replumb my entire house, and that's not the case. So in many situations, ThermaSkirt can actually be installed onto existing pipework. So you can remove radiators and you can install ThermaSkirt directly onto the existing pipe. Now, in this example, you can see that you've got a primary 22 mm flow and return down the middle, and it's branched off individually to each ThermaSkirt system. And there's a little 2-port valve, a little TRV valve on the skirting and a lock shield to balance it. So effectively, the ThermaSkirt is just a radiator plumbed in the exact same way. You can also plumb ThermaSkirt back to a manifold like you would with underfloor heating, and that's often done if people are having underfloor heating downstairs and ThermaSkirt upstairs. But because we're talking about retrofit specifically in this example, we'll work on the basis that you're using existing pipework and doing pipework replacements. So let's talk about disruption to microbore. So this is a study that we did with a local authority that has microbore. So they have a 22 mm flow and return on the landing, and they had microbore pipes, 10 mm running out to each of the radiators. Now, those radiators needed to be upsized in order to allow for low temperature of the heat pumps. And as a result, they needed to replace that microbore with new 15 mil pipe. Now, if you look at the example on the left, if I just zoom in to this, the yellow shaded area shows you exactly where the floorboards will need to be lifted in order for the pipework to be run. Now, in this particular house, the joists run right to left, which means that the pipe needs to penetrate 1, 2, 3, 4, 5, 6, 7 joists in bedroom 2 and bedroom 3. It actually becomes quite a complex pipe run because it's council, they do it all in copper. So they had to effectively remove all of the furniture from this room, rip up all the floorboards, and install brand new pipework to each of the radiators. So the yellow shaded area effectively shows you the area of disturbance necessary to install that pipework. And on the right hand side, you can see the area of disturbance necessary to install new 15 mil pipe to the ThermaSkirt. So because the skirting is fed from anywhere in the room, anywhere along the length, rather than having to position the radiator and run pipework to the radiator, you actually choose where the most convenient location is to start the pipework, and then that's where you begin your ThermaSkirt run. So you can see in here, the furniture wasn't needed to be removed from the rooms. The floor covering didn't need to be removed. What they did was they basically cut off the old microbore pipe and just left it dead. And they ran new 15 mil to each of these locations. So obviously you can see there's one in bedroom 3, there's one in bedroom 2, and there's one in bedroom 1. And this is the area of the landing that they needed to disturb in order to get that new pipework in. So that was a 75% reduction in disruption, which again is a major impact on cost. It's a major impact on time, and for energy companies in particular, that's a massive benefit. The other thing that really isn't considered that often, and I don't know why, but I guess it's just not that obvious, is that you don't need to replace radiators with ThermaSkirt. The ThermaSkirt can be used to supplement existing radiators. So when many energy assessors go and do, say, a heat pump calculation, they might find that out of the 10 radiators in the house, 6 of them are already big enough to run at lower flow temperatures, and that's because they were installed prior to double glazing and loft insulation going in, so they're effectively already oversized. And you may find that in a heat pump spec on a retrofit, that only 30 or 40% of the radiators need to be upgraded, as they call it. I mean, I call it downgraded, but upgraded is the term they use. But what you can do instead of replacing that radiator with ThermaSkirt is you can actually supplement it to make up that shortfall. So if, say, for example, you have a 1 kilowatt heat loss, and the radiator that's in there on a heat pump is producing 600 watts. Well, rather than putting 1 kilowatt of ThermaSkirt in, you only need to make up the 400-watt shortfall. So you can leave the existing radiators in, tee off the supply pipes, and put in a run of skirting. And that basically means that the customer hasn't got to compromise on space, hasn't got to compromise on aesthetics, but they do also get the additional heat output they require. So ThermaSkirt can be used as a tool by heat pump engineers to meet the heat losses without having to throw the baby out with the bathwater and just supplement the existing rads. Again, reducing space, reducing time, reducing cost for the consumer, but not compromising on that radiator size. So if we're talking about lifestyle benefit, let's talk about thermal comfort. So this is the test data from BizRia. It's not our own test data. This is independently completed test data. ThermaSkirt is tested to BSEN 442-1, like any radiator is. And you can see here from the thermography, the difference in thermal comfort from the same energy input. So this is the same room running at the same flow temperature with the same amount of heat being delivered. So there's 800 watts being delivered by the radiator and 800 watts being delivered by ThermaSkirt. And what it shows is that ThermaSkirt is far more like underfloor heating. And the upshot of that is that improved thermal comfort means a reduction in complaints around heat pumps. If a resident moves into the house and their house feels comfortable, they've got no reason to call up and moan. Safety and accident prevention. So this is something that is so commonly overlooked, particularly with radiators because we're so used to them. But the ROSPA statistics are clear. 87% of radiator-related injuries are impact injuries. They're mainly in the under 5s and the over 65s, and they're effectively people running into them, falling onto them, dropping them on their feet, and so on. Burns obviously account for a very, very low number of injuries, and that's effectively impossible on a heat pump anyway. But what it shows is that obviously if you increase the size of the radiator, if you make it stick out from the wall further or you make it even longer, then you're only increasing that risk of injury or accident. Mold and damp prevention, again, is another major concern now, particularly for local authorities since AWAB's law came in. But radiators, as we know, get used to dry clothes on. And on a heat pump, that can be very detrimental not only to the performance of the system, but it means that clothes can take a long time to dry. And it means that moisture is being released into the air, which ultimately condenses and causes black mold. So removing the radiators has this unforeseen benefit, which means you eliminate the ability for people to dry clothes on them. Because despite common perception, it isn't free to dry your clothes on radiators, particularly on a heat pump. You will affect the performance, you will affect the output, and you will affect your thermal comfort. Now, obviously, we have thousands of case studies. There are some people, particularly in our comments on social media, who like to remind me that ThermaSkirt doesn't work, but we've done 80,000 systems. I think about 85,000 actually now. We've had a particularly good year. And over the last 18 years, we've done some very, very hard to heat properties. They're not just brand new, flagship pilot scheme projects like this one for Wigan Council, but they're also standard 1800s, 1920s, 1950s, concrete, timber, passive. We've done every single property type you can imagine. From this, which is a retrofit of a 1950s council house, through to this, which is the brand new future home standard that we did with Barrett's, testing ThermaSkirt in the chamber at Energy House 2 on a heat pump. If anything that I've said has resonated with you, then great, reach out. My email address is at the end of this video. Dependent on who you are, will change the likelihood of how likely I am to respond, obviously. But if you send me an email, I will read it, of course, and I appreciate any and all feedback. If you're an installer who's watching this and you'd like to be trained on installing ThermaSkirt, head over directly to our website, click on the Become an Installer, and there's a registration section here where you can effectively register your interest in becoming an installer, and you'll go straight onto our training program. Thanks very much for your time, and I hope to hear from you very soon.